Okay, so when you got something like this, where's the first place? Where do you start? Let's make a derivative. Yeah, so what we could do here is we could fall back to our steps. Remember, I've mentioned to you that I've got a whole set of directions in my head, don't I? And I really am trying to get these in your head too. Step one. Okay, so for step one, what we're going to do is we're going to compute the derivative, which is going to be 5x to the fourth minus 20x cubed. Everybody good with that? What else are we going to compute while we're here? The second derivative. Might as well while we're here. So the second derivative is going to be 20x cubed minus 60x squared. So we got those two things done. Now that you have your first and your second derivative, and be careful to always label them because we've got three values going. And in fact, what I'm going to do right now, before I go any further down the road, is, he's reaching into his backpack. What am I going to do now? I'm going to plug these things into, I'm going to pull out lunch, that's right. This is going to be y1, y2, y3. Okay? I would strongly encourage you to just go ahead at this point. Come on. There we go. Okay, so I'm going to put in x to the fifth minus 5x to the fourth plus 35, and there's the y value. I'm going to put in 5x to the fourth, subtract 20x to the third. There's that one. And we're going to do 20x to the third, subtract 60x squared. Okay. I've got those three into the calculator. What's the next step? What's step two? That's right, we're going to look for critical values, inflection points, maxes, mins, all that good stuff. You find your maxes, mins, and inflection points by taking the first derivative and setting it equal to 0. What that means is we have 5x to the fourth minus 20x cubed equals 0. Now, you want to be careful here. We do not want to divide through by an x cubed. We want to factor it out. If we factor out, and we can factor out a 5x cubed, if we factor that out of the first term, it's going to leave us with x minus, if we take a 5x cubed out of the second term, we're going to have 4 equals 0. This gives us then either 5x cubed equals 0 or x minus 4 equals 0. Everybody good? On the left-hand side, divide by 5, we get x cubed is 0, and the cube root of 0 is 0. So on the left-hand side, we get x is 0. On the right-hand side, solving for x, we get x is 4. Our potential critical values are x equals 0 or 4. Our potential critical points are 0, comma, something or other, 4, comma, something or other. How am I going to get those? The calculator. Okay, so I'm going to go back. I'm going to go to the table. I'm going to delete whatever is laying around in that table. I'm going to enter in 0, enter in 4. Well, wait a minute. Do I want y1, y2, or y3? y1, that's the y value. So that's going to give us 0 is 35. At 4, wow, This is going to be a negative 221. Now, just a comment. Personally, while I'm working these things, I always try to make my critical values and stuff stand out in some way, because there's so much math going on here that it's easy to lose this otherwise. So you may want to underline them, write them in a different color, something or other that's going to cause those to stand out for you. Does that make sense? Second thing we're going to do here is we're going to solve for the second derivative equals 0. And this second derivative equals 0 is going to give us locations of inflection points. So I'm going to come back up here, pick up the second derivative, which means that we're going to take 20x cubed minus 60x squared equals 0. Those two terms both have a 20 and an x squared in common. So we can rewrite this as 20x squared times x minus 3 equals 0. Everybody okay so far? This then gives us possible inflection points. Just like the critical points, we don't know for sure if they're truly critical points or not, but they're possible inflection points of 0, comma, something or other, and 3, comma, something or other. Where did I get 0 and 3 from anyway? Okay, we solved this 20x squared equals 0, which means x is 0, right? And then we can do the x minus 3 equals 0, which means x is 3. That's where those two came from. Using the y value when x is 0 that we have already computed, it's 35. Going to the calculator and entering in 3 for an x value, you get a negative 127. Okay, my possible inflection points are those. Is everybody good? Yep, because in the ordered pair, the 35 and the negative 127 are y values. And anytime we want a y value, we go to y1. Okay? Yeah. Yeah, it's good. Keep things in mind, what's going on. Okay, are you okay with this? There's a lot going on there, isn't there? Step 3. Okay, going to take and draw a line. Going to save some space, draw another line. Like that. The first line is going to provide information about the first derivative. The second line is going to provide information about the second derivative. We're going to take this just a little bit at a time. Okay? And it's very important at this point to go carefully and not try to do 42 things at once. Okay? I know people get aggravated. Geez, Chuck, really? Can't we do more than this? Yeah, you can do more than that, but it's going to trip you up somewhere. Okay? On our first derivative, we have critical values at 0 and at 4. Now, before I put 0 on that line, I scanned. Critical values 0, 4. Inflection points 0 and 3. So I've got some idea of how far in each direction I need to be able to go. Because my leftmost value of everything that's up there is x equals 0, I can put that there. If we would have somewhere on the list had x equals negative 15, I couldn't have put the 0 in that location, could I? I would have had to move it closer to the middle. Okay, I'm also going to put x equals 4. Well, I'll put that over here. And, let's see here. Let's pick some other color. Maybe something like this. Okay, because this first line is a 0 for y1 for the derivative, and it's a 0 for the second derivative, I'm going to extend that line down below the second derivative. Is that a dark enough color for you to be able to see, or do I need a different color? It's okay. Sometimes looking at it from the angle, it's not quite clear. Okay, at 4, I'm going to do another one of these lines. However, this time, and this is more of a bookkeeping thing, it's not mathematically incorrect to do or not do what I'm describing here. However, I did not extend it below the second derivative. And the reason is, at x equals 4, is the second derivative 0? No. So I'm just going to leave that alone. I'm going to put in x equals 3 here. When I do that, the only thing that is 0 at x equals 3 is the second derivative. It helps me kind of keep track of what's going on. And hopefully we'll see how this plays out here in a minute. Okay, what we now need to do is let's pick another color. How about something like green? That'll be different and stand out. I need to know what the derivative is in that leftmost interval. What is a y value or an x value that I could plug in on that leftmost interval? -1. So I'm going to go to the calculator, enter in -1. When I enter in -1, do I want the value at y1, y2, or y3? y2, it's 25. All I want to know is it's greater than 0. Because I was careful to not extend that yellow line all the way up, I know that this first derivative information on the next panel will go all the way from 0 to 4. So I just pick some number between 0 and 4, like 2. Okay, so that gives me is -80, so the derivative here is going to be less than 0, and if you want, you can remind yourself it's less than 0. It's less than 0. You can put it at several locations along there, so that whole interval reminds you that, oh yeah, it's less than 0 that whole way. Does that make sense? Then we move to the rightmost panel. Well, it starts at 4. I'll put in 5. Well, that gives me, holy mackerel, 625. Glad I didn't have to figure that out by hand. That would have been a little on the large side. There. Now we have the information about the first derivative. Before I go on any further, I'm going to write down what that first derivative means. On the leftmost interval, see it where it's y prime is greater than 0? That means the function is doing what on that interval? It's increasing. So I'm going to write down, before I forget, that along here it's increasing. Then there's this long stretch in the middle where the first derivative tells us the function is decreasing. So I'm going to put down decreasing, decreasing, decreasing. Just so that I remember, all along there it's decreasing. The rightmost interval, the function is increasing. Is anybody lost? Make sense so far? One of the things I would encourage, and I haven't seen anybody's handwriting in here who's an absolute train wreck. My handwriting used to be bad, and when I started doing the math, I found out, bad handwriting and math don't go along, because it's hard to tell what's going on. And not keeping things in nice, neat lines doesn't work either. I've shared with you, right? I started doing my homework on what? McDonald's bags. I just tear them open and work. I would. I just tear them open and write around the grease marks and stuff and let it roll. But when you come back to it, man, is it hard to study. Okay? So, do things neatly and you'll have a lot less troubles. Okay, so let's go after what's happening here on the second derivative. On the second derivative, we have the derivative here is 0. Just like up here, the derivative is 0. We have the second derivative here is 0. And we have the first derivative up here is 0. So I've got those labeled now too. I'm going to do the leftmost interval for the second derivative. With the leftmost interval, what value of x could I plug in? -1. And the good news is we've already plugged in a -1, haven't we? So if I do the second derivative here, I go back to my table, and where am I going to look for the second derivative value? y3. It says -80, so that's less than 0. Then I'm going to look in this interval. Well, what's in between there that I could use? Something like 2? If I plug in -2, what does the second derivative turn out to be? -80 again, which is kind of interesting. But, yeah, I want to make sure. Okay, -80, less than 0. Then, we've got this third interval with second derivatives. Be careful. Notice that the yellow line does not extend all the way down to cut into where the second derivative would equal 0. Does that make sense? We need to select a value somewhere over in here. Would 5 work? Yeah. So I'm going to use 5. Why'd you pick 5, Chuck? Well, it was already on the chart, already on my table on the calculator. Came out to be 1,000 greater than 0. Okay, so with that taken care of, let's come back and talk about concavity. We have information here now about concavity. On the leftmost interval, concave up or concave down? Concave down. Then we have this interval here. On that interval there, the second derivative is negative. What's that mean? Concave down. Then, on this interval here, the second derivative is positive. Good. That means concave up. Are you okay so far? Okay, so we've got a lot of information on there. I'm going to move things up so that the rest of it just disappears and we can just focus on this. This tells us what the shape of the graph is going to be on each panel, if you would, of the graph. Let's see, what color might stand out here? Let's try this, see what happens. We have several different panels. Our leftmost panel goes from -infinity, that first yellow line. In that region, the function is increasing and it is concave down. Now, increasing and concave down is shaped like that. Be careful. Sometimes people get a little zealous and they go, whoop. That is not increasing and concave down. Why is that not an increasing concave down shape? It decreases on part of it. So be very careful about what you're putting up here. Okay? Okay, so for this first piece, the graph is shaped like that. The next panel or section goes from x equals 0 to x equals 3. On that, what's the graph doing? Decreasing and concave down. Decreasing and concave down. Once again, being careful not to loop things around, goes like that. Does that make sense? Here's where you got to be careful. The next panel goes from x equals 3 to x equals 4. Do you see that? Be careful. On that interval, the function is decreasing and it is concave up. Decreasing and concave up is shaped like that. Then on the last interval, from 4 to infinity, it's increasing and it's concave up. The shape there, increasing and concave up, looks like that. Is everybody okay? We're getting closer to being able to graph this thing. Before I go any further, I want to check out this x equals 0, x equals 3, x equals 4. X equals 0. To the left it's increasing, to the right it's decreasing. X equals 0 is a what? It goes from increasing to decreasing. Close. It's a maximum. Okay, it's going to be a maximum. So this is going to be a maximum point here. X equals 3. Now, Brianna, you ready with your answer? It goes from decreasing to decreasing. It's an inflection point. Then at x equals 4, what do we have? It goes from decreasing to increasing. It's a minimum. Does that make sense? I'm going to bring my 3 points down. Let's see. One of them is going to be 0.35. One of them is going to be 3, negative 127. And the last one's going to be 4, negative 221. Those are the coordinates of the 3 points from the max, the min, and the inflection point. Is everybody okay so far? All right. What I'm going to do now is do something like that. I've got to watch my scale. Why do I have to watch my scale on this? We've got big numbers. That's exactly it. We've got numbers going all the way down to negative 220 and numbers going up to 35. So on the y-axis, I got to pick my scale kind of carefully. I'm going to do something like 50. Okay. It's not completely comfortable, but it might work. So here's a negative 50. Here's a negative 100. Negative 50. There's negative 200. And there's a negative 250. It just about fits. Not quite, but close. I'll extend that. Going up we only need to get up to 50, so I'll just do the 50 here. Do I need to go by 50s in the x direction? No. I can go by 1s there, can't I? So I can go 1, 2, 3, 4, and that'll about work. Good so far? Then what I'm going to do is I'm going to plot my 3 points. Well, let's see here. Hey, let's try gray. I've not done gray. We're going to do 0, 35. Right there. 3 is going to be at a negative 127. Well, that'll be something right about there. 4 is going to be a negative 221. Something like that. Everybody good? Then what we want to do is we want to take a look at what are the shapes of the 4 different pieces of the graph. Our leftmost section is going to need to look like that. And I was sharing with somebody earlier in office hours. I don't know if this will work for you, it works for me. I think of it as being pieces of wire, and at the inflection or the max-min points, they're just being welded together. So what's happening is, on the leftmost portion, I need a piece of wire that's shaped like what's in that gray circle. So I'm going to take and move a gray piece of wire in that's shaped like that, and boom, there it is. Then the next piece in this graph that we're building needs to be shaped like that. So I'm going to get a part that's shaped like that, put that in there. The next piece I'm going to weld or put in is shaped like that. And it's going to come down like that. And the last piece is going to be like this. And there you go. Now it's not quite done. What do we need to include here? That's right, the coordinates of the points. This is going to be 0, 35. This is going to be 3, negative 127. And then this one is going to be 4, a negative 221. Does that work? There's a lot going on with this. Does it make sense where it's handy to put stuff in for y1, y2, and y3? Okay? It takes a lot of the busy work away and allows you to just focus on the things that are, I don't want to say more critical, but could require more attention. Does that make sense to everybody? You okay? Now what's going to happen on the quiz, very honestly, is I'm going to ask you to do step 1, step 2, and then step 3. And I'm going to ask you to stop there, and that's problem 1. On problem 2, I'm going to give you 2 lines with the information on them. Okay? And it's going to have information like this one does, but just going to give you this information and then ask you to create a graph using the information on those lines. And the reason I'm doing it that way, breaking it up into 2 pieces, asking you to first do all the analysis on a function. There it is. Do all the analysis. Stop. Go to a completely different situation. Do the graph without any of the analysis. The reason I've broken it up into those 2 pieces is, what if you made a mistake somewhere up here? Could that come up with some horrendous thing to graph? That could get really ugly, couldn't it? So I've broken it up like that so that even if the top part gets ugly and out of hand, when you get down to question number 2, okay, things are back under control again. Okay? So when you see it and you're trying to figure out what's going on and why do you do that or whatever might be going through your mind, that's the reasoning behind it. Are you good? Okay? All right, it's showtime.